Hi class, today we're going to be discussing physical and chemical properties as well as looking at phase changes for states of matter. So let's go ahead and get started. We're going to be looking at information from chapter 1. So what is a physical property? It is the characteristics of a substance that can change, doesn't mean that it is going to change, but can without the substance becoming a different substance. So if the property were to change, you would still have the original substance that you had to begin with. You can see these changes happen without changing the identity of the matter. But again, it's a property, so we're not actually discussing the change happening. But if the property were to change, it would be physical, so the substance would still have its same identity. Some examples would be density. The color of a substance can change without it actually being a different substance. The melting point is a physical property. The odor or the smell of a substance, as well as its volume and a state of matter, which we're going to talk about a little bit more in detail. So again, those are just some examples of physical properties. And again, physical meaning that the physical component of it is there, and that if a change were to happen, the substance would not change its identity. So we're going to talk a little bit about the differences in 3 of the 4 phases. There is plasma as a 4th phase, but we don't really have to get into that because plasma is not something in a general chemistry setting that we're going to be dealing with very much, but we will be dealing a lot with solids, liquids, and gases. So just want to give you some of the properties or some characteristics of each state of matter so that you can understand a little bit more about how they are different. And even though they are the same substance, the substance can exist in different states. So when we look at compressibility, so I like to call this its squishability, so how much it can be compacted or compressed. A gas is going to be highly compressible, and if you look down here at the illustration, you'll see that you have individual gas particles that are there. And when you have those individual particles, when you have those individual particles, it makes it very easy for you to compress them into a smaller area instead of not having that in some of your other states. When it comes to the compressibility of liquids and solids, those of course are much less compressible. Again, in the liquid, you'll see that you do have some randomness in your individual atoms, but they're pretty close together, so it's very hard to compress those into a smaller given area. In a solid, they are aligned very definitively, and so it's quite difficult to make anything compress there. When it comes to the density, so again, thinking back to looking at those math problems that we did from chapter 2, density is mass divided by volume. For a gas, the density is going to be very low. Again, if we look back down our illustration, there's very few particles in a given volume. Whereas in a liquid and a solid, those are going to be high. Again, those illustrations give you that piece of information. For the volume, it is going to fill a container if it's a gas. So whatever the container is, it's going to expand, kind of that opposite of compressibility. And looking down here at expansion, it is going to expand to fit whatever container it's in, whereas in a liquid and a solid, those volumes are definite. You can't really change the volume of a solid or a gas to fit a container. If I pour 10 milliliters of water into a graduate, it's going to be 10 milliliters of water. I can't make that water become more than 10 milliliters. For the shape, again, gases are great in their flexibility in that they are going to change to take on the shape of whatever container you have. Think of a balloon. Okay, if we blow air into a balloon, the air is going to take on the shape of the balloon as it is filled. Whereas if you were to do that with a solid, that's not going to happen. The same thing will happen to the shape for a liquid. Again, so if I put water in a balloon, the water is going to take on the shape of the balloon. And then if we were to put a solid in there, nothing's really going to happen to the shape of the solid. Diffusion. Okay, diffusion is basically when we have particles of the substance that move from one area to another. So if I were thinking about diffusion of a substance, let's think if I were to spray perfume on in one corner of a room, a perfume is going to be liquid propellant that becomes a gas, and so that gas is going to diffuse rapidly. That's why eventually you can smell the perfume on another side of the room, because those gas molecules of the perfume are moving through, again, with the air molecules. So it's very easy for you to smell that diffusion for a gas, so the diffusion is rapid, whereas for a liquid and a solid, those are going to be much slower. Expansion, again, this is, can it become larger? Very much the opposite of compressibility. With heating, you are going to have expansion of gas. It's going to be high, whereas for liquids and solids, those are low. Solids very rarely expand, at least noticeably to the naked eye. Liquids can expand some, but most of the time the threshold is low enough that when you heat it, it becomes a gas, and so you have a change in state. Kinetic energy, this is the amount of movable energy, so energy in motion. You should remember that from some of your physical science classes. For gases, this is going to be the highest, whereas the solids are going to be lowest, because, again, if we think about the arrangement of particles as well as some of these other properties, if you have a lot of area to be able to move, then your kinetic energy is going to be higher than if you're stuck over here in a very ordered, close, confined area. So when we look at our kinetic energy, of course, the gas is going to have the highest and our solids are going to have the lowest. Just to put into words what these pictures are illustrating, we have total disorder of the arrangement in our particles of a gas. They're going to be far apart from each other. Even when we compress them, they're going to be further apart than if you were to see a liquid or a solid. If you compress them enough, they will turn into liquid. Think liquid nitrogen, liquid oxygen. You compress something strong enough, then it will actually create a phase change. Motion is random for those gases. As we get to the liquids and the solids, we still have disorder in the liquid. The particles are closer together, and we have what's called a sliding motion. So the particles slide over each other. If you think about all liquids, they kind of have that sliding motion in and of themselves as a whole. Well, it's because their particles are doing the same thing. And then finally, for solids, very ordered, very close together, and the only motion that they can really have is this vibration and rotation. So basically, you could think of each of these little atoms as kind of shaking, and they could flip or turn around, rotate within their given area, but there's not going to be a whole lot of movement. Okay, and that just gives you a great overview of the properties associated with each phase for substances as we go forward. And again, phases are associated with physical properties. All right, moving on to chemical properties. These are characteristics that describe the ability of a substance to change into a different substance. So it's no longer going to be the substance that it initially was. These are not things that we can identify by looking at them. At least without there being a change in the identity. Examples would be the flammability. So does it catch on fire? Its toxicology. Is it caustic? Is it corrosive? Those are things that are associated with chemical properties. And so the chemical properties, basically you would have to do some kind of experiment reaction, a chemical reaction, to see if that was a property of that chemical. You would have to try and put it in a flame to see if it was flammable. You might have to do a pH test to determine its acidity or basic alkalinity to determine how caustic or corrosive it was. put it into water, put it to see its solubility. Does it, and then to react it with something else to determine if that substance is going to have that chemical property. Next, we're going to see if we can figure out what these actually are. The answers are down there, so it's really not figuring it out. But if you read through the properties first, you figure out if it's physical or chemical. If we look at the boiling point, okay, so alcohol has a boiling point of 78 degrees. That would be, boiling point would be when we're taking something from a liquid to a gas, and so it is physical. That's a phase change thing. Diamonds are very hard. Hardness is a physical property associated, again, with it being a solid. Sugar ferments to form alcohol. Okay, we're making something new. Fermentation is just the process that gets it there, so that would be chemical. Metal conducts electricity, so we're looking there that an electric current can flow through the metal, but does the metal stay the same? Yes. There's not a difference in the metal. It's not like you put electricity through it and it becomes something different. If we have copper wiring for our electrical outlets, the copper stays copper. It doesn't change, so that's a physical property. And then leaves turning color in the fall. This will be chemical. Another great way to figure out if it's a physical or chemical property, as well as when we start talking about changes, is when we look at these, the two chemical that we have, once we have alcohol, it's very hard, almost impossible, to turn the alcohol back into sugar. And so that helps us to tell that it's a chemical property. The fermentation component is what makes it a chemical property. What it actually turns into is a chemical change, and we'll talk more about that in our next lecture. It's the same thing with leaves. Okay, once the leaf turns color, it's dying, basically. You can't make a yellow leaf turn back into a green leaf. It's just not going to happen. So the process is the actual chemical change. The turning of color is a chemical property of that. So that's kind of how you can figure out the differences. So hopefully that helps you understand a little bit about the properties, as well as giving you some examples and also looking at the phases themselves. Now, going into phase changes, so there's going to be the possibility for a substance to change phase. This is still a physical property, so it's still the same substance. Water is a great example because it's something we all see relatively every day. In the solid form, you would have ice. In the liquid form, you would have liquid water, and in the gas phase, you would have water vapor. Water vapor is huge in the atmosphere. Think about all those hot, humid summer days that you've been dealing with in the past couple of weeks, as well as if you are cooking, the steam that comes up, the steam in your shower, all those different things are the liquid, are the liquid turning into a gas, or the gas water vapor. And so looking at those phase changes, we can see that there are terms associated with the changing of the phases. And you can see it both graphically, and then I have a slide that shows you it just straight up words. But let's just talk quickly. When I take a solid and I take it or make it into a liquid, we call that in chemistry fusion, also most notably termed as melting. But when you fuse something, you are making it go from a solid to a liquid. When you take a liquid and make it into a solid, you're freezing it. So in the olden days, before there were ice makers in your refrigerator, you would take an ice tray, put liquid water in it, put it in the freezer, and it would freeze into solid ice. If you take anything that's frozen out, or if you take frozen ice out, unfortunately, especially in Georgia summers, you are going to have it melt. The Yeti cups have done a great job of trying to keep that from happening quite so much, but still, eventually the ice will melt. And the next part of this, you have liquids going to gases. It's vaporization or evaporation when it goes to a gas, and from a gas to a liquid is condensation. A great easy thing that you can see in your bathroom when you take a shower. So the liquid water comes out hot, it vaporizes into the air, and then if you're like me and always forget to turn on the the bathroom vent to try and help get some of that water vapor out. You go and you get out of the shower and there is liquid water on your mirror and you can't see anything because it has condensed. So that is a great little everyday seeing of this phase change happening. The one that we don't see as much, and so is a little more, I need to learn that, is from solid to gas and gas to solid. When I take a solid and I make it a gas, that is called sublimation. And then if I have a gas and I go straight to the solid, then it's deposition. Certain chemicals do this a lot better than water. Ones that have a very low melting boiling point. Iodine is a great one that hopefully we'll get to see at least a demonstration of that, where it sublimates and deposits quite quickly. It's really cool. It has to be done in fume hood, but we can do that. So that gives you a visual. And again, as I said, here is another, just a written form of that chart. And so that gives you some details about those phase changes. And that's it for this lecture. Next, we will be talking about physical chemical changes, which most of that, or a good portion of that, will be this phase change stuff, but we'll also talk about when you change some other things physically, and then also those chemical changes. Take some time to go back and look especially at those phase pieces of information about the compressibility, that kind of stuff, so that you understand what those properties are of each phase, as well as the phase change terminology. So good luck with that, and we'll see you next time.